Hey, I'm here today to talk about some uh, introductory information, overview information regarding the fireplane dispatcher problem. This is your semester project in the Linux System Administration course. And in order for you to solve this problem, with bash scripting, you first really have to understand what the problem is. So that's where I'm trying to set the stage today. Let's first look again at the actual problem. We're told that airplanes are standing at the ready at one of several airports, or one plane at each of several airports, and that you're going to write a program so that the best choice of plane is dispatched to a fire. There's information about the way the data is going to be provided to you. But let's take a look, because I've broken this down into maybe some more bite-sized pieces. So again, airplanes to dump water and fire retardant on forest fires stand ready at several airports. The airports are located by their latitude and longitude. Each of those are given with 3 integers, a measurement in degrees, 1 in minutes and seconds. And then the fire location itself is also represented by those same degree, minute, and second measuring units. You're given a file, fire.txt, and this is the file to supply your input for your script, your program. The data in that fire.txt program is going to consist of line 1, the number of airports. In the example, we see it as 5. That number indicates how many lines to follow our airport data. So in this case, we have 1, 2, 3, 4, 5 more lines of airport data where I've got the latitude, degrees, minutes, and seconds in blue, and the longitude, degrees, minutes, and seconds in an orange color here. The final line in the file is the fire location, which is also given in a degree, minute, second unit, latitude, followed by longitude. So I thought that I would try to present this to you graphically. So I have a simple Cartesian coordinate system here where I have latitude along the x-axis and longitude along the y-axis, and I've put onto the canvas some stars which will represent airport locations, and a little starburst here that will represent the fire. So our goal for each and every airport is going to have to be to calculate the distance between that airport and the fire, so that we can ultimately choose the minimum distance, and that will be the airport from which to dispatch. So how do we find this distance between airport and fire? And it's going to be just a little bit of geometry, right? So for each airport, there will be a longitude distance and a latitude distance. And we are, of course, given that data as degrees, minutes, and seconds. So you could go through a long, drawn-out process to try to take that degrees, minutes, and seconds and convert it to meters or miles. But let me just ease your mind a bit and let you know that the program that we're asked to write isn't asking us to find a distance per se. It's just asking us to find the closest. So the actual unit of measurement, we have a little bit of flexibility there. So I'm going to give you a hint. Why don't we, instead of having this measurement in degrees, minutes, and seconds, look at the distance as just seconds? Let's consult a web page here. So how much distance does a degree, minute, and second cover on your maps? This is from the U.S. Geological Survey. And right off the bat, we're going to find that the distances vary. A degree, minute, and second of latitude remains pretty constant from the equator to the poles, but longitude can vary greatly. Well, we're not going to be that worried about, because we're working in a small geographical region. We're assuming these planes are within probably a county, several counties of location, not across the entire globe. Okay. So one thing to take a look at with longitude here is that well, let's take a look at longitude. We can see that 1 second measures out at 80 feet. The minute, 60 times that, right? 4,800. The degree, 60 times that. And for the latitude, it's a little bit off from that, but trust me, let's just go with that. 60 seconds is a minute, and 60 minutes for a degree. That will be precise enough to give your calculation the correct answer to find the closest airport. Okay, so let's go back. We find how many seconds of longitude the airport measures at. Find out how many seconds of longitude the fire measures at. And then we want to subtract one from the other. It really doesn't matter which direction you go in, because as you're going to find out, or you already know, in the distance formula, it's the square root of a squared plus b squared to get the distance, the hypotenuse, right? So let's get this distance. Say with latitude, we get the latitude in seconds of the airport. the latitude in seconds of the fire, take the difference to get that delta. Now we have one leg of a rectangle, two legs of a rectangle. We can then calculate this hypotenuse, which will be the distance of that given airport from the fire. We can use that same philosophy for every airport to fire. And then the trick or the goal is going to be for you to come up with data storage methods. And we did talk about arrays in another video so that you can have some memory from one calculation to the next, and then determine which measurement is smallest. That will indicate to you which airport from which to dispatch planes. All right. I hope this sets you on a firm footing, and start looking at the problem so that you have plenty of time to think it through.